All right, I want to go over diagnostic process today. I want to demonstrate how this works even with nothing in the shop. There's no cars in here today. We got all caught up. We had a pretty good week. Everything went smooth in the last 4 or 5 hours of my week. I've got a bunch of other stuff to do, but I wanted to run through this really quick. This is one we had this week that, with a little bit of logic and a little bit of planning, we were able to whip through this pretty quickly, and I want to demonstrate how we can do this even with the vehicle not here. So step one is identify concern, including symptoms. Doors lock, won't unlock. And it is a 2005 F-350 Superduty 6-liter diesel. So a really nice truck yet too, not just some beat up piece of crap. They don't even care. This guy wants this to work properly, so that's why it's here. So the doors lock but don't unlock. Take the necessary time to fully understand the theory of operation, not only the systems affected, but how the systems work together to complete a specific task. So in this case, what is the task? The task is the doors won't unlock. So we know we need to figure that out. Why won't the doors unlock? How do they normally unlock? Sorry about the fan, but it's cold here still. So, if you see, this is the module, the vehicle security module that's responsible for interpreting the door lock switches. And here are all the actuators for the doors. This is a 4-door truck. So, if the doors will lock but not unlock, it's pretty safe to say that the ground is good. Both lock and unlock circuits use this ground. And how does this work then? There's only a single circuit coming out to the switches, switched to ground. So not knowing anything else about this, what do we expect to see on these wires here in order for this computer to know that the switch is switched to ground when it's active? And the only possible answer is some sort of voltage. I don't even care. It could be a few hundred millivolts, could be 12 volts, could be 5 volts, could be 8 volts. I don't even care. Don't need to know. What I do need to know is there is voltage at all 4 of these pins, because when whatever specific one is grounded, it pulls that voltage to 0, and the ECU sees that as an active switch. I want to make sure that makes sense, because that's how a lot of switches work in body control modules, vehicle security modules, stuff like that. That's a pretty typical design, but you can see that's the only way that's going to work, is the switch gets switched to ground, it pulls down some sort of voltage to 0, and then that is how the module knows that that switch is active. So we went to the vehicle, verified that unlock doesn't work at either switch. Okay, so we know both switches will lock the doors, but neither switch will unlock the doors. So our problem's not on the ground side. We know our module has enough power and ground to control the lock circuit, so it's safe to assume it has enough power and ground to control the unlock circuit. So what are we left with? We're left with either checking voltage here at the unlocks, right at the switch, to see what kind of voltage we have, and then compare it to the voltage on the other one and assume that they're both the same, which they probably are, right? Or we can go directly to the module and check for voltage at this pin, and then check for voltage at that pin, and see if they're the same, and we can actually ground each one And we already know that the door lock one works when it's grounded, right? Because we do that through the switch. So we can go right here and manually ground the unlock circuit and see if it unlocks the switches, right? Or we could hook a scanner up and see what the live data says in this module. Well, this is a 2005. It's 20 years old. This does have a bus circuit, which is right there, and it goes up to the DLC. So we could just hook a scanner to this. So let's go back here and see where we're at in our process. So now that we know how the system works, and we're kind of an idea of what we're going to do for testing, using the information gathered in the previous steps, list all of the possible causes for concern, and associated symptoms. Okay, so we kind of went through that, right? We know now what could possibly cause the problem, and we went over the other symptoms or potential symptoms to have some kind of an idea. So now we're going to list the possible causes, which we did that. We walked through that, right? Possible causes, determine the ease of testing of each cause. Okay, so we can go here or here. Both these switches do come out relatively easy. I could hook a scanner up, or I could go right to the module. This module is actually behind the ashtray in this vehicle, and it's kind of a pain in the butt to get to. So, being that I don't want to work very hard, we're going to start our testing at the least invasive and most inclusive test we're able to use. Well, it seems like if we get access to the module through the scanner, we should be able to see live data that tells me whether the module knows the switch is working and whether it's deciding to actuate the actuators, right? So we're going to hook up a scan tool, right? Well, we'll go over, hook up a scan tool. I hooked up 2 different scan tools. No comm with this module. Now what? Well, am I going to condemn the module? Do I want to go down the rabbit hole of discussing or trying to decide why I don't have comm with that module? Or do I want to go back to physical circuit testing? Well, we did the least invasive test first. It was pretty inconclusive because we can assume the module is working properly because it does lock the doors. We don't have communication with it, and we don't have a scanner that'll communicate with it, so that's kind of dead in the water. Am I going to keep going? I documented that information. Am I going to keep going on that route, or do I want to go do some physical testing? Well, what I think is the best course of action is to go do some physical testing. So I was able to get access to this module by pulling the ashtray down. I believe it was the ashtray. It might have been just a little cubby, but we pull that down to get access to this, back probe it, pull it down to measure for voltage. And I did have a few hundred millivolts here and a few hundred millivolts here, and verified the door lock works, locked it. Okay, that works. Got over here, shorted that pin to ground, and the unlocked works. So I know the module is capable of unlocking everything, and I also know that I probably don't have 2 faulty switches. I could get access to the switches and measure for voltage here, and measure the voltage here, and compare voltage drop to try to decide what's going on. But again, I don't want to pull those switches out. They're not that hard to get out, but that's work. I don't want to do work. So what's the next best approach? Well, if I can assume a wire's broken, I'm just going to assume that, because I know the door's locked. Both switches probably aren't faulty. So I'm going to get access to one switch, the driver's door switch, because that one's going to give me easy access and enough information to assume that if I know this switch is faulty, I better go test this switch. If this switch tests good, then I know I have a problem between here and here. Okay, pull this out, test at this switch. And I don't have the voltage I need here, but when the switch is in the unlocked position, when it's in the unlocked position and shorted to ground, I have a path to ground here. So I know this switch is good. this switch might be faulty, but I don't care because this switch is good and I don't have the voltage I need here. Where am I going to go next? Right there, that splice. This splice, after looking it up in service information, is in the driver's kick panel and floor sill by the driver's door. So I'm going to pull this up and inspect that. And when we did pull that up and inspect it, we found a crusty green splice, pulled it apart, cleaned it up, fixed it, everything works. So back through here. We're going to start our testing with the least invasive, most inclusive test we're able to use. We're going to document all of the stuff, all the information gathered during the first round of tests and review, which we did. Using your knowledge of the device and the information gathered, you must make a decision to continue testing or verify the cause for concern. Well, once we got here and verified that the module works, we know that it has to be downstream. Here, somewhere is the problem. The easiest access is here. We tested here. We don't have voltage here. We do have voltage here. We know there's a broken wire somewhere in here. The easiest and most logical spot for there to be a broken wire is at this splice here, especially on a 20-year-old truck, so we went there first. So, doing all of that, we decided we found the problem, and we did, and we fixed it. So no more testing is needed. If we did need more testing, say we fixed that and it worked here, it didn't work here. Well, then we have to go here and continue testing and verify that the passenger door lock switch works. But we don't need to because everything worked when we were done. So we found a broken splice. But we probably didn't spend more than 45 minutes total on the vehicle. And how we can do this is through strategy and a process. Just thinking through how the system works, how's it going to function, what does it need, where to work, and what is it missing. So it could be it was missing voltage here is what the problem was. But that's not but we could have tested here first, realized we were missing voltage, but we already knew that because we know the locks work and the unlock doesn't. So we already knew, more than likely, if both these switches don't work, we don't have the voltage that we need from the module at the switches. So I don't want to waste time pulling that apart until I've verified the voltage is coming out of the module. I hope that makes sense. And then once we verified that the module functions, the voltage coming out of the module is okay, then it's safe to assume we have a broken wire at or before this splice if both ones don't work. And again, we only accessed one because I wanted to know if I had one good switch once we got that far. Because we could have just had two bad switches. I mean, it'd be weird and rare, but it could be. So once we get access to this switch, we check for voltage here. We didn't have the voltage. We know there's a break somewhere between here and here. And we also know it's very likely that we have a break somewhere between there and here as well. Where do they share? The splice. So that's why we went to the splice. We found the problem relatively quickly and got it fixed, problem solved. I use the same process for every single diagnostic event that I do. So every single problem I attempt to solve, I go through this same process every single time. And you can see you could work through it really quickly, but it's the same process. Super vague and just enough to know that if you get stuck, if you're trying to figure out how this works and you don't know how it works, or you're getting testing results that you don't understand, you can go back to this process and figure out where the breakdown is. Do you not know how to test something? Do you not know the information? Do you not know how it works? Do you not have the proper tools to test what you need to test? This whole procedure is designed to tell you what you're missing to get the job done. Thanks for watching. I hope this helps.